So, like I said, it's a lot easier to do the visual logic flowchart, and this is the entire run 1, all of it. Okay. So, first of all, the requirement is that there can be any number of employees in this list, a list of employees, right? It does not say how many. So in this example, there's John Smith, Jane Doe, Mark Manning, and to end the information, we have ZZZZ, a fictitious employee, right? So there could be any number of them here in between, assuming from 1 onwards to any higher number, 10, 15, 20 employees in the company. The very last one is ZZZZ, so assuming that there's no real employee with that name. These 2 lines are optional. You don't have to put in their hour of work if there's no such employee, right? Or you can put in 00, depending on how you do the flowchart and Python program. So what we want is exact duplication of this on the input-output in Visual Logic as well as Python. Python comes later because normally if you make the flowchart first, isn't it a bit easier to do the programming in any language? It is, right? Flowcharting is always more insightful and gives you a better idea of what to do or how to solve the problem. Okay, so first of all, you got the name, hours worked, and hourly rate of pay for each employee. So here's that information. John Smith, 50 hours work, 10 hours. Now, why did the pay turn out to be $550, not $500? Overtime, over 40 hours, 1.5 times, that's the law, right? So $15 an hour for 10 hours, that's $150. And for 40 hours, the regular pay at $10 an hour, so that's $550. The next person happens to work exactly 40 hours, so at $15 an hour, they pay $600, right? And finally, this person has a lot more overtime, so it turns out to be $840. I've checked this for accuracy. Now, for this one, there should not be pay equals 0. It doesn't make sense, right? And you need to print the total pay for all the employees. So 550 plus 600 plus 840. Now, let me give you, okay, first, these are the hints. Write a while loop inside a flowchart, of course, to read in just the employee data and print it out, nothing else, no processing. Don't worry about the sum either. Then you can do simple processing without worrying about overtime. You can just multiply those 2 numbers and see what the pay turns out to be. Then you can put in overtime, okay? Then include overtime and finally produce the total pay. So for some of that, let me just point you in the right direction in the book. Please note the input-output is interlaced. Interlaced means a little bit of input, 1 line of output, a little more input, 1 more line of output, and so on. Finally, when the loop stops, because the name is ZZZZ, by the way, the loop should stop based on the employee name, not anything else. Okay? If the name happens to be ZZZ, stop. Then you print this final line of output. Of course, you should have added on the current salary to a total. Okay? So with that in mind, let's go back to the book. And I think it's in chapter 8. Oh, we don't have an editor for that. I just have to go forward somehow, put in the page number.
84.
84, thank you. A little bit more. Yeah. Probably the very first, this nested if then else, chapter 7, this is the repetition. You got to read, oh yes, page 84 for the book. That happens to be 92 because of the table of contents, etc. But anyway, this is the structure of a while loop. You have a Boolean expression, first you check that. And if it is true, you keep repeating these statements over and over. Okay? Till that becomes false, then you go to the next thing. So that's the pseudocode for it. You always write some sort of initialization is necessary, otherwise the loop may or may not start. You write while and the Boolean condition here and do, that's pseudocode. Bunch of statements, any number of them here, and while to indicate where the while loop ends. This is not the same as Python, yes.
When you say initialization, I'm assuming you're setting up some variable to become either a counter or a
Yes.
down counter. Is that what that means?
Yes, we are coming to the example very shortly in the next minute or so. So let's take this problem 8.1 and I'll directly go to the flowchart. I'll come back to the details Tuesday. Okay? So this is the initialization. Count is set to 1 and while it's less than equal to 3, I'm going to repeat this. So what am I going to do? Print the counter, which is 1 right now, increment it. Count equals count plus 1 means change the counter to the next value, add 1 to it, and repeat. Is it still less than equal to 3? It is, right? It's 2 right now. So go ahead and print it out again. So the output produced is 1, 2, 3. All this trace you can go through, and finally the output is 1, 2, and finally it will print 3. So the trace is shown in lots of detail. I don't think there's any excuse not to do it correctly on the test. So finally when you're done, you can have more statements here, but we just choose to stop. So this is a very simple example of a program or a flowchart or pseudocode to print 1, 2, and 3. Now can you modify to print 300, up to 300? Just change this number to 300, right? So that's the whole point behind loops. You can vary the number of times you go through the loop. Okay, that's called a fixed loop because fixed iteration means you know ahead of time how many times you're going to go through the loop. Now, the problem we just discussed, we do not know ahead of time how many employees there are. You do not have a count of employees. You're not entering 3 here.
You just know what name to stop on, right?
Exactly, you just know the name you need to stop on. Or this ZZZZ actually can be the null string, 2 double quotes together, where you know there's really no name for that employee. You don't have anybody with any, I mean, that's not true in the entire world, right? Everybody has a name, right? Could be in Chinese or some other language or anyway. But I prefer to use ZZZZ because it stands out and you can actually type in 4 Z's, right? By the way, do not type in double quotes for Visual Logic or for Python. Where are we here? Okay. So the real useful example is not this one, but the next one here. Sample data is 90, 80, 75, 85. These are grades for 4 students. But we don't know how many number of students there are ahead of time. We do not enter 4. Why bother? Because the computer can count just as well or better than we can, right? And the 0 indicates that's the end of the list. Now I could have -1, I could have +1000, but we choose 0 as the sentinel. Okay, nobody assuming has a 0 in the class.
3 people on this list.
Some people do. Yeah, the 3 people who did not take the test have a 0 right now. So, but we won't enter their grades, right? We want to take the average of people who don't want to enter those who missed the test or got a 0 in there. Anyway, don't worry about it. So if you add up all these numbers, you get 330, right, for the total. And then you know there are 4 people, so the average should be 82.5 because you divide. So first flowchart, then maybe pseudocode, then the Python. So there's plenty of example. This is a very nice example for this problem, okay? So including the flowchart here. See, get the score while it's not 0, keep repeating. I don't know why those numbers are not showing up. Probably some defect in my PDF reader. These lines are crooked as well. But then finally you print the average, calculate it first. See, there's a dependency here, right? And this is the initialization section where you need to put the counter equals 0, sum equals 0, and get the very first score. Otherwise, this sentence doesn't make any sense, right? If score doesn't have a value, How do you know if it's going to go to the right or to the false, right? Okay, so if you want to do this problem today, examine this flowchart carefully, understand it, try and run the program too. What's wrong with that? This is the pseudocode, and it's free of Python, as you notice, except for this not equal is the same in Python. Accidentally, that's the same. But we do have a start, stop, while, and while. This loop keeps going and going and going till the score is 0. When it's 0, it comes out here, does this, and so on. So this test is made once every time in the loop, okay? Not constantly. Some people do get confused with that. In other words, if this is true, you do the next statement, the next statement, the next statement, and while go back and check this condition. If it has not changed, you have an infinite loop. Infinite means it will keep going forever, but what changes it? This get score has to be duplicated. Okay? If you don't duplicate this statement, you're stuck in an infinite loop. Because score will not change. So if I enter 80 over here, it will remain 80 and it will keep adding and adding and adding and become bigger and bigger and bigger. Counter or sum will overflow eventually. So the Python program which corresponds to that is right here. You can cut and paste it into idle and run it. Not idle, but the new window. And here's the output. Okay. And I won't worry about the trace because we'll go through it Tuesday. But let me point out one more flowchart in chapter 7 where you have the overtime salary. And it's already given to you basically. It may be even in 6. I believe it's probably the last example in chapter 6. Just faster than trying to search for it. Yes, it is. Here, let's see, here it is. And once again, with the flowchart first, or actually we'll start here. Problem 6.3 on page 70 in the PDF, probably a little bit, 62, thank you. It's offset by 8, right? Okay, so here, this is overtime pay. Regular pay up to 40 hours, you pay the person at the given rate. And if there's overtime pay, you're going to pay for the extra hours 1.5 times the rate. So this is a pseudocode. And again, a print is good. It prompts you to enter the rate of pay first. Otherwise, we don't know if it's hours or rate that we enter. Why we don't need the employee name is because we are just processing one employee. Why bother with the name? You could ask for the name. So if hours is greater than 40, then you know they worked overtime hours. So the correct pay is for the first 40 hours at the given rate. For the extra hours, you get it by subtracting 40 from hours at this. Now you're sure that hours exceeds 40. So it could be 45. So for the remaining 5 hours, you get that new rate. That's why we need this condition and we need to subtract 40 out of it. If some other country has 30 hours working week, then you got to put 30 here and here, right? And 30 here also. Otherwise, if the person has not worked overtime, that is, hours is less than equal to 40. Therefore, you give the person the correct salary, hours times rate. In either case, when you finish the if statement, as shown by the end if, you're going to come and print this. Correct? Any questions? So, of course, if somebody's worked 0 hours, this will still work. Anyway, this is the flow chart. I wish we had prints over here and here, but Visual Logic says please enter the rate, please enter the hours anyway. So if you think of it as Visual Logic, you don't have to put in the prompts. Okay, and calculate the pay. If this is true, you do this expression. If it's false, you do this expression. Now don't make a mistake over here. If you by mistake write false here and true here, it's all messed up, right? Or if you change the expression to some other Boolean expression, it may not work correctly. So this is the correct one. And you print in either case. Commonly, if statements join together. In the older days when we had Fortran, COBOL, etc., 50 plus years ago, they did not necessarily come together, and therefore there was a lot of confusion. It was called spaghetti code because it looked like spaghetti in a bowl. So this is the Python program. Essentially, you got to take this program and merge it with that 8.2 example we just did. Okay? So that's all I'm going to say for it. And if you're curious to look at your test, I'll return it to everybody today and collect it back because 3 people have still to take the test.